So, hello everyone. My name is Shara Ortiz. Welcome to the session on rapid leaf senescence of chrysanthemum cut flower. I did my undergrad in Colombia National University, and then I did my master's here in US at Clemson University. And currently I'm working in Apex horticulture in New Jersey. So let's start. So chrysanthemums are one of the most popular cut flowers worldwide, but this flower presents like a really fast leaf senescence. It presents symptoms as chlorosis and necrosis in the first 7 days after we place these stems in a vase. During my master's, we did like different observations of a lot of different cultivars. And at the end, we could conclude that there are cultivars that are more sensitive than other ones, and the sensitive ones present small leaves, green and dark color flowers, and usually they were like in a spray form. The performance of the leaves, it's highly variable between and within shipments. Our hypothesis at that time was that are these symptoms or this phenomenon related with a carbohydrate depletion? So the objective of the research was, we got like two different objectives. The first one was to determine if this rapid leaf senescence in cut chrysanthemums would be related to carbohydrate depletion. And in the second one, we evaluate pre-harvest and post-harvest strategies to reduce these leaf symptoms in chrysanthemum stems. So as a little bit of background, through the process of photosynthesis, the plant are producing different sugars such as glucose, fructose, sucrose, that are used during the day in the carbohydrate metabolism. So the plant is moving this sucrose from the sour organs to the sink organs, such as flowers and young leaves. And all the sugars that the plant is not using during the day are becoming stocks of starch, as a starch. So for the first part of this research, we evaluate 3 different techniques that alter these endogenous carbohydrate concentrations. So the techniques were, we compare different flower forms of the stems. We compare what happened if we harvest those stems in different times during the day. And we also evaluate the performance of the stems when we add some sugars into the base solution. So for the first technique, we took the same cultivar of these chrysanthemums, and we organized the plant as a disbud form and as a spray. So in the disbud form, we just kept the main flower bud. And for the spray form, we kept all the lateral flower buds. But again, they were plants from the same cultivar, and this arrangement was made in the field, maybe like 6 weeks after after those cuttings were planted in the field. For the second technique, we compare what was the stem's performance in the vase when we harvest those stems early in the morning, and when we harvest those stems around noon. So for the third technique, we got the sugar addition into the vase solution. So we separate this technique in two different experiments. So for the first one, we just use sucrose in highest concentrations. So we compare what was the performance when we placed stems in a vase with 0 sucrose concentrations, with 0.1, and with 0.2 grams per milliliters of sucrose concentration. And for the second part of this technique, we compare different types of sugars such as dextrose, fructose, mannitol, and sucrose at these 5 different concentrations that went between 0 to 0.1 grams per milliliter. So for each treatment, we use water in a vase with an addition of 5 milliliters per liter of Flora-Life Hydrofluor 100 that allow us to keep the pH between 3.5 and 4.5. And then we add the sugar as correspond. So this experiment, as I mentioned before, was run, some of them prior to harvest or in the field, and the other ones were performed in the lab at Clemson University after those stems were shipped. So as a methodology, the stems were harvested and then transported to the post-harvest area. So in this area, the stems were placed in the hydration solution. During the transportation between the field and the post-harvest area, those stems were placed also in a bucket with another transport solution that it's also the same solution used for this hydration in the post-harvest area. Then those stems were placed inside the boxes that were placed in the cooler and then shipped for a total of 7 days of storage and transport. 6 days, I'm sorry, of storage and transport. And then these treatments were, these stems were treated and then placed in vases. And all the symptoms were recorded 10 days after we placed those stems in the vase. So Sunshine Farms and Flores El Trigal, there were like 2 different companies that helped us during this research. So they were the ones who grow the different stems that we use for all the experiments that we run. So from Sunshine Farms, we work in 3 different farms, and we used the cultivars Bomber Green, Green Screen, Peridot, and Shrek, all green cultivars. And for Flores El Trigal, we used 7 different cultivars. So we got Alligator, Mark Twain, Molly Purple, Paintball Sunny, WhatsApp, Zumba, and Leech. Most of the cultivars were usually sell as a spray form. We just got Liche as a disbud-form chrysanthemum. Here we got all the symptoms recorded and how was the symptom progression for each symptom. So we record leaf chlorosis, veinal necrosis, marginal necrosis, and wilting that are symptoms related with senescence. And we evaluate this progression in percentages, going between 0% symptom severity to 100% symptom severity. So for the first technique, the flower form, in this graph, we got how was the symptoms severity recorder that goes between 0 to 100%. For this experiment, we use 4 different cultivars: bomber green, green screen, peridot, and shrek. In white, we got the disbud-form stems performance, and in black, the spray form stems performance. So for this experiment, we observed that for 3 of the 4 cultivars used, the symptom severity was much higher for the spray form than for the disbud form. And that was the same behavior for all the other symptoms recorded. So in here we got 2 pictures of the cultivar peridot. Here we got the spray form stem, and here a disbud form, the same cultivar, and how those leaves perform at the end of 10 days. This picture was taken 10 days after we placed these stems in the vase. We conclude that the higher flower count of the spray form exceeds the source capacity of the leaves more rapidly than the single flower disbud form. For the second technique, this time of harvest, I would like to zoom this. So in this graph, we got the same chlorosis severity, also recorded between 0 and 100%. For this experiment, we used 11 different cultivars that were alligator, bomber green, green screen, liche, molly purple, Mark Twain, peridot, paintball sunny, shrek, WhatsApp, and Zumba. And we found that for and we got in white the morning harvest, and in black the afternoon or noon harvest. So for this experiment, we found that for 8 of the 11 cultivars evaluated, we observed higher symptom severity in the stems that were harvested in the morning compared to the stems that were harvested at noon. And this behavior was also repeated for the other symptoms recorded. So in the left, we got stems from the cultivar shrek. In this first picture, we got stems that were harvested during the morning. And down here, the stems that were harvested around noon, and how those leaves performance after 10 days then these stems were placed in the vase. In this third technique, this is the 3A. So in this graph, we got the symptom recorded that was a chlorosis severity that went between 0 to 100%. For this experiment, we used 10 different cultivars. We got alligator, bomba green, lychee, molly purple, peridot, paintball sunny, shrek, WhatsApp, and Zumba. In white, we got the performance of the stems that were placed in a 0 sucrose solution. In black, we got the stems that were placed in a 0.1 grams per milliliter sucrose solution. And in diagonal, we got the stems that were placed in a solution of 0.2 grams per milliliter sucrose solution. So the results of this experiment show us that for 8 of the 10 cultivars evaluated, show us a higher symptom severity in the stems that were placed in a 0% or 0 grams per milliliter sucrose solution compared to the other treatments. And it was the same for all the other symptoms recorded. So in the left, we got peridot stems. Here, we got the stems that were placed in a 0 grams per milliliter sucrose solution. And here, the ones that were placed in a 0.1 grams per milliliter sucrose solution, and how their leaves perform 10 days after these stems were placed in a vase. We also found that for the stems that were placed in a 0.1 grams per milliliter, the chlorosis, marginal necrosis, and wilting was lower than the other treatments. And that for the stems that were placed in a 0.2 grams per milliliter sucrose solution, the venal necrosis was lower compared to the other treatments. For the 3B, for this one, we use 4 different types of sugars. So in this graph, we got in the left the chlorosis severity that went again between 0 and 100%. In the lower part, we got the 5 concentrations that we use for each sugar. So we got the concentrations between 0 and 0.1 grams per milliliter sugar concentration. In the upper part, we got the 4 different cultivars that were used, that were bomber green, peridot, shrek, and WhatsApp. And in these lines, we got the dash lines are the dextrose. We got the dot lines that are fructose. We got dash dot line that is mannitol, and we got the continuous line that is sucrose. So for this experiment, we observed that mannitol for all the cultivars present like the highest symptom severity for all the different concentrations that we tried. And also we observed that consistently the lower symptom severity was when we use sucrose in concentrations that went between 0.025 and 0.075. And it was the same for the other symptoms evaluated. So in the left, we got pictures of the cultivar WhatsApp. And in the left, we got the stems that were placed in a 0 grams per milliliter sucrose solution, and then stems that were placed in a 0.05 grams per milliliter sucrose solution. And how their leaves performed 10 days after these stems were placed in a vase. So as a conclusion of this first part of the research, we observed that, or we conclude that the high incidence of leaf senescence symptoms occurred when there is a low carbohydrate supply at harvest. So this happened when we harvest these stems during the morning, early morning. Also, when there is a high carbohydrate demand, and we observe this when we compare the spray form versus the disbud form. So a higher number of flower buds in the spray form. And also when there is like a low post-harvest supply of carbohydrates. And we observe this every time that we try the 0 grams per milliliter sugar in the vase. So for the second part of this research, we explore different pre and post-harvest strategies for reducing these leaf senescence symptoms in cut chrysanthemums. So as a pre-harvest strategies, we try with the application of PGRs in the field, also biorational applications such as Bacillus subtilis and salicylic acid. As a post-harvest applications, so these applications were done in the packing house. So in here we varied the hydration time at different times that went between 0 hours to 24 hours hydration. We also try placing the buckets with the flowers in different environments. So we compare the stems that were placed in a cooler place with a low temperature to other stems that were placed in buckets outside the cooler. We also try with PGR applications added in the hydration solution, and also sucrose addition in the hydration solution. And after shipment, we try with the addition of sucrose in holding solutions and also in the vase. So for the PGR strategies, as it was mentioned before, for the carbohydrate metabolism, there is like a source-sink relationship that is working inside the plant during the day. So there are some methods that could altering this sourcing relationship, such as the plant hormones. So we got ethylene inhibitors or cytokinins or gibberellic acid. Those can alter this sourcing relationship. And it has been reported that when we got a higher concentration of endogenous carbohydrates, the ethylene sensitivity, it's going to be reduced inside the plant. So for the first strategy that I'm going to show you today, I'm going to show you just the ones that show us like a significant improvement in leaf performance. So for this first strategy, I'm going to show you the PGR applications in the field. So there were weekly spray applications, and we try with these 3 different products. So we add benzyl adenine at 10 parts per million, 1, 2, and 3 weeks previous to harvest. We also try with a mix between benzyl adenine and gibberellic acid at 10 parts per million each molecule. Also at 1, 2, and 3 weeks previous to harvest. And we also try with 10 parts per million of thidiazuron in the same 1, 2, and 3 weeks previous to harvest. For this specific experiment, flower deformation was recorded. The other strategy that shows like an improvement was the PGR applications in the hydration solution at the post-harvest area. So for these ones, we prepared like the commercial solution. So we kept the pH of the solution between 3.5 and 4.5 using citric acid. And we had the different PGRs evaluated that were, again, benzyl adenine at 10, 20, and 40 parts per million. Also a mix between benzyl adenine and gibberellic acid at 10, 20, and 40 parts per million. And also a thidiazuron and 10, 20, and 40 parts per million. For this experiment, we leave the stems hydrated for 4 hours in the post-harvest area. For the last strategy, so we use sucrose again. So we evaluate this sucrose when we apply that sucrose in the hydration solution, also in the holding solution after shipment, and also adding that sucrose in a vase solution. But we observed that when we apply that sucrose in the post-harvest and also as a holding solution, it didn't show us an improvement in leaf performance during the vase life. So I'm going to show you just the results for the addition of sucrose in the vase solution. So for this one, we add the 5 milliliters per liter of hydrofluor 100 again, that allow us to keep the pH between 3.5 and 4.5 during the base solution preparation. And we try these 5 different sucrose concentrations that went between 0 and 0.1 grams per milliliter sucrose. And this solution was prepared just one time during the whole life or during the whole vase life. So we didn't change the vase solution or add like more sucrose or water during these 10 days in the vase. So these experiments, as I mentioned before, were performed in the field, in the greenhouses, also in the post-harvest area, in the packing house, and also after shipment during the post-harvest evaluation at Clemson University. As a methodology for these experiments, again, the stems were harvested and then transported to the post-harvest area. Here, the treatments were done in the hydration solution. after that hydration, the stems were placed inside the cooler and then shipped to the Clemson University for a total of 6 days of storage and transport. Then the treatments were done in the holding and also base solution. And all the symptoms, incidence, and severity were recorded 10 days after the beginning of the vase-life evaluation. So for the first strategy, for the PGR pre-harvest application, in here we got the different PGRs that we used that were BA plus GA, and TDC. And here we got the number of applications previous to harvest. These were weekly applications, so we got 1, 2, and 3 weeks previous to harvest. And here we got the 4 different symptoms recorded related with leaf performance. And also we got flower deformation. So in here, we got the symptoms severity and the letter that is showing us like the difference between the treatments. So for this strategy, we observed that when we use TDC applications, we reduce the symptom severity in the leaves, but it produced also a flower deformation. So here we got some pictures of the cultivar peridot. This is the control 10 days after these stems were placed in the vase. So the leaves are completely collapsed. These are stems that were treated with 1 application 1 week previous to harvest of 10 parts per million of TDC. And the leaves look really good, but we start seeing like this flower abortion in some of the lateral flower buds. Then for 2 applications, this is the mix of BAGA 2 weeks previous to harvest. So we got, again, good leaves or good leaves performance, but flower deformation. And also when we apply TDC 3 times, 3 weeks previous to harvest, like 1 application at week 3, the other one at week 2, and the other one 1 week previous to harvest, we observe flower abortion and most of the flower buds. So these are the results for the PGR post-harvest applications. So in here we got the different treatments that we applied. So we use the same BA plus GA, and TDC at 10, 20, and 40 parts per million. So in here we got the 4 different symptoms severity recorded. And for this one, for this experiment, we observed that the best treatment was to add 20 parts per million of the mix of BA plus GA, and also when we add TDC at 40 parts per million, we observed like a reduction of the symptoms in the leaves. So next are some pictures of the cultivar Shrek. Here we got the control. Also, we got the stems that were placed in a 20 parts per million of VA plus GA, and also the 40 parts per million of TDC. And these pictures were taken 10 days after the beginning of the vase-life evaluation. For the last strategy, we got the addition of sucrose in the vase solution. So in here, this is the chlorosis severity that was recorded that went between 0 and 100%. For this experiment, we used 5 different cultivars: bomber green, green screen, peridot, shrek, and WhatsApp. And we got in light gray the addition of 0 sucrose, in diagonal the 0.025. In gray, we got the 0.05. In white, the 0.075, and in zigzag, the 0.1 grams per milliliter of sucrose in the vase. So for these experiments, we observed that for all the cultivars, when we place the stems in a 0 grams per milliliter sucrose, the symptom severity was much higher than when we add some sucrose in the vase. And it was consistently showing us that when we add concentrations between 0.025 until 0.075 sucrose in the vase, we reduce significantly the leaf senescence symptoms. And it was the same for all the different symptoms recorded. So here are some pictures of the cultivar WhatsApp. So this first picture are stems that were placed in a 0 grams per milliliter sucrose, and in the bottom we got the 0.025 grams per milliliter sucrose solution. So as a conclusion of this part, we conclude that PGR applications in the field show a significant reduction in the leaf senescence symptoms. However, flower deformation and abortion was promoted. Also, when we add PGRs in the hydration solution immediately after the stems were harvested, that showed a significant reduction in the leaf senescence symptoms. And also, again, when we add sucrose concentrations between 0.025 and 0.075 grams per milliliter in the vase, that significantly reduced the leaf symptom severity across all the cultivars that were tested. Also, we measure how these carbohydrates were changing over time after these stems were harvested. And we measured these non-structural carbohydrates. For here in the graphs, I'm going to show you just 2 cultivars that were green screen and peridot. We evaluate sugars such as glucose, fructose, and sucrose, and also starch. So for this, in this graph, I'm showing you the mix between glucose, fructose, sucrose, and also starch. In dot line, we got the cultivar green screen, and the solid line is the cultivar peridot. So in here, we measured these carbohydrates. We took leaves of these stems just after the stems were harvested. Then we also took leaves at the end of the hydration period in the post-harvest area. And also after the stems were shipped And when we receive the stems and we place them in the vase, also we took leaves 4 days after the vase-life evaluation begun. And at the end of these 10 days of vase-life evaluation. So after these measurements, we observed that for both cultivars, the leaf starch concentration decreased from the moment of harvest until the start of vase life. Like this graph is always decreasing. And for peridot, even after the hydration period, the starch concentration was really low. Also, the concentration of the combined sugars, glucose, fructose, sucrose, decreased during the hydration period, storage, and shipping. And when we place these stems in the vase with a low concentration of carbohydrates, that is like the commercial flour food concentration, that increased a little bit of the sucrose, of the sugars concentration in the tissue. So as a summary of this whole presentation, we conclude that the high incidence of leaf senescence symptoms occur when there is a low carbohydrate supply at the harvest time, when there is a high carbohydrate demand, and when there is a low post-harvest carbohydrate supply. Also, we can reduce these symptoms severity in the leaves when we apply PGRs such as thidiazuron in the field, but that can create this flower deformation. So it's not like the best treatment to try. Also, we can reduce these symptoms when we add PGRs in the hydration solution just immediately we harvest these stems. And also when we add sucrose in the base solution in concentrations between 0.025 and 0.075 grams per milliliter sucrose in the base. So thank you so much for your attention, and thank you all the American Fair Endowment, for the companies of Sunshine Bouquet, Flores and Trigal, and Clemson University. Thank you so much.